Alright, so we've done graphing systems to solve. Reminder, what are we trying to find? We're trying to find the point of intersection where the two equations, in this case we're doing linear equations, have the exact same value, value for x and y. So what we're going to be looking at today with substitution is a little bit more of an algebraic way to find those answers. So reminder, again, so like we're saying, we're trying to find this point. We're trying to find this x value, comma, this y value for where these two equations are going to be equal. So we see the word substitution. That should ring a bell for us as far as what that means. Substitution meaning, think the word substitute, taking the place of, in general for algebra, we're talking about taking the place of a variable. We're trying to find this point here, and we have these two equations, x equals 2, y equals negative 2x plus 7. What we should see pretty clearly right now is, oh look, we already have part of our equation. We know that x is equal to 2 for this one. The question is, how can we find the y value? Well, if we know that the x value has to be 2, how can we find the y value? We can take this and we can plug it in wherever we see an x value. So in order to figure out what y is, if we take this value of 2 and substitute it in where we see x, negative 2 times 2 plus 7, so negative 4 plus 7. This is the basic idea of substitution. The y value we get is 3. We already had the x value was 2. Substitution means taking that value and plugging it in to the equation for the given variable. So only for x. And if you wanted to check this, x equals 2 is a vertical line. And then negative 2x plus 7, down 2 over 1, down 2 over 1. Notice what point do we intersect at? It would be 2, comma 3. Just like we got from solving. This is the basic principle behind substitution, is taking this value and plugging it in. However, so this is a little bit of a simplified version. What we're going to be looking at is not an equation where x equals a number or y is already given to us a number, but what if we have two linear equations? How can we do this how can we solve using substitution? Well, it's the same principle. If we take, so I'm going to kind of jot some steps down here. Step 1 is you want to make sure you have one variable isolated. And variable isolation means all by itself. So in other words, your equation says y equals or x equals. Step 2 is you are going to substitute for that variable in your second equation. So in this equation we have that y is equal to 3x and y equals x minus 2. What this is telling me is anywhere I see a y, I could actually place in place of it, substitute in place of it, a 3x. So what I'm going to do in the second equation is I'm going to find where the y is, and I'm going to substitute 3x in its place. Substitute means it's going to take the place of. Y isn't going to be there any longer. Think about a substitute teacher. If I have a substitute teacher, am I still in the room? No, you're not going to have a substitute and the teacher stay there. So the 3x is going to take the place of the y. So we'll rewrite the second equation, 3x in its place, and then keep the equals x minus 2. What does this allow us to do? Well, now we can actually find a value for x. So can we solve for x? And then step 3 would be to solve for your variable. So subtract x from both sides. 2x equals negative 2. Divide by 2, divide by 2, and x is equal to negative 1. So we substituted in so that we could find the value of one of the variables. So for our answer, we know it's again an x and a y, whoops, an x and a y value, a point. So we know the x value is negative 1. How can we find the y value now? Well, if we know that x is negative 1, again, we can substitute that in somewhere we see an x. So step 4, substitute the value into, and I'm choosing, if you notice, I'm choosing to substitute in the first equation. Does it really matter? Well, let's see what value we'd get from the the second equation. 3 times -1 is -3. -1 minus 2 is -3. And it doesn't matter which equation you substitute into. Substitute the value into either equation. So our value where those two intersect would be -1, -3. How can we check this? Well, from our first day of looking at systems, our first video, how can you check this? You can actually go through and plug it in to the first equation, plug in your y value, -3 equals 3 times -1. Double check and make sure that's true. It is, so it works for the first equation, but your point has to work for both equations. So -3 equals -1 minus 2. -3 equals -3. That's true also, so that is our solution. That is correct. So we want to check our answer, and I'll label this as check. So that was my I do. Here's your you do. You try it. Pause it, try it, and now here's the answer. If I see y equals, anywhere I see y, I can put 5x minus 10. So I'm going to put 5x minus 10 right in for y here. So I rewrite the second equation without the y, but keep everything else the same. Now, if I solve, I can figure out the value of x. 2x minus 10 equals 8. Add 10 to both sides. 2x equals 18. Divide by 2, divide by 2, x is equal to 9. So my point would be 9, comma. If I plug it in, and I'm just going to go for the first equation. Oh, sorry. Oh yeah, that was right. X and the y. 5 times 9. And then minus 10. So 45 minus 10. Y would equal 35. So 9, comma, 35 would be the point of intersection. So we've seen just the basic idea of substitution. Where we go from here, and what we're going to see most of the time, is situations where substitution is going to be a little bit more involved, because what makes these equations really easy is that we have this y all alone. We have the variable already isolated. But what if there is no variable isolated? That doesn't mean, oh gosh, we can't do substitution, we have to use something else, we have to go ahead through and graph it. What if there is no variable isolated? Then isolate one of them. Most of the time when we're doing these problems, we are looking to isolate the y value. When we've been doing our graphing, we want to make sure our equations are in y equals mx plus b form. But in general, if there's not a variable isolated, or even if there is, it doesn't matter which variable is isolated. We're talking about substitution. We're just trying to say, okay, if I see an x or I see a y, it's equal to this other expression. So I'm going to plug in this other expression. So for instance, if I take this equation, and you can use either equation and either variable. If I take x minus y equals 5, and I want to isolate a variable, yes, I can go through and isolate the y value, but it's going to be pretty easy if sorry, I had to pause, but to go back to where I was, it doesn't matter which variable I isolate. If I want to isolate the x, for instance, how would I get that alone? Well, choosing to get the x alone may be a little simpler, because all I have to do is add y to both sides, and then I end up with x equals y plus 5. So if there is no variable isolated, you have to do the work. So now I have the two equations, 2x plus 4y equals -2, and now x equals y plus 5. So x equals y plus 5 tells me anywhere I see an x, plug in y plus 5. So in my other equation, boom, there's an x. I'm going to write that same equation, but instead of x, I'm going to write y plus 5. So 2, the one tip I have last, I guess, to give you is when you have a substitution, think about when you substitute a value in, I tell you, this is the time where putting it in parentheses makes the difference. So anywhere I saw x, I put in y plus 5, and then I write the rest of the equation. Because this second equation here is telling me that x is the exact same thing as writing y plus 5. These are equal. So now distribute and solve. 6y plus 10 equals negative 2. Minus 10, minus 10. Oops, that's a weird 10. 6y equals negative 12. So y divided by 6 on both sides, y is negative 2. So my point, something, comma, and notice I solved for y first. So you got to make sure where you're putting this point, your answer, and then also when you substitute this back in, it's going in for y, not for x. So where can I substitute this negative 2 in? Well, I could substitute it in here. I could substitute it in here. I could substitute it in here. Anywhere I see a y is fine. And I'm going to choose to substitute it in to this equation. Anywhere I see an x and a y equation, it's fine to substitute in to find my answer. And again, to check it, plug in the x, plug in the y for both equations, and make sure they match. I'm going to leave you with a problem like this to complete on your own. Oh, actually, I forgot. I have this slide. And this was just an example to think through. Which variable is going to be the easiest to isolate? You could always choose to isolate the y's. You could always choose to isolate the x's. But in general, thinking about which variable is easiest to isolate. And you're looking for what's the fewest steps. So for instance, thinking about in this first example, you can use the first equation, you can use the second equation, but why would this variable be the easiest to isolate? Well, think what step I would do. I would only have to subtract 3x from both sides. In the second equation to the right here, which variable is going to be the easiest to isolate? Well, I see no number in front of y here, no number in front of y here, but this has a negative sign, so a negative 1. This variable would be the easiest to isolate. You're looking for one step. Which variable would I want to isolate here? Well, probably this y, because all I have to do is divide by 5 on both sides. And again, sometimes it's the y's, sometimes it's the x's. What do you notice about all the variables that I would choose as the easiest? That doesn't mean that's the one you have to choose, but the easiest, you're looking for a coefficient of positive 1, or in this case, this was a one-step, and I'm going to put a positive sign. That was a one-step isolation. So here's going to be your chance to practice. Isolate a variable, substitute in. I'm going to choose, make sure you pause and try this. I'm going to choose to isolate this y value. So I'm going to add x to both sides. Y equals x plus 1. Now all I have to do is take that x plus 1 and plug it in for y in the other equation. So 2x plus, 2x plus x plus 1 equals negative 2. There's a positive 1 to distribute, which means still it's x plus 1. So 3x plus 1 equals negative 2. Minus 1, minus 1. 3x equals negative 3. Divide by 3. X equals negative 1. So my point is negative 1, comma. And if I plug this in for x, y equals negative 1 plus 1, which is 0. The point of intersection would be negative 1, comma, 0. You can check your answers. That's the nicest thing about these solving problems, is that you can easily check these answers. Plug them in, and tomorrow we'll practice some more substituting.